Okay, so today I'm going to show how our MATLAB code works. So our MATLAB code, it will be calculating the natural frequency, the temperature, the KEQ, and the CEQ for each of our ideas. So these ideas, they have different number of isolator as well as different location where the isolators are located at. So sometimes the location are varying and sometimes the number can be varying also. So these are the ideas that we have generated. Okay, so I'm going to explain our code. So first we clear all the data to make sure that the cache from our previous run won't be interfering our current run. And then we define the parameters which are not the C, the K, and our MEQ. As you can see here, the MEQ is the same for all of our ideas. The only things that are changing is actually the location and the number of isolator, which consists of the spring and the damper. So for the MEQ, we can just get it from the MEQ that we have already calculated from our that we calculated manually before this that we calculated for our original setup. So we are just going to use the MEQ for the same MEQ for all of our ideas, and then we define the ratio of A over B for each point. So these isolated that are located at different points. So the A will be the original distance of the point to the pivot, and B will be the new distance of the point to the pivot. So these are all the points that are presented in the questions. As you can see, E and G, they have two different points, two different versions. The V indicating that the isolator is placed vertically, and H indicating that it's placed horizontally, because for these 2 points they are located at the corner. So there are two ways that we can locate this isolator. Okay, so after this we define the position of our isolator for each idea. So the first array is for the original idea, the idea 1, idea 2, idea 3, idea 4, idea 5, and so on. So you can see that even though the number of isolator is not the same, but if I change the alphabet, the letter in the array, I will also get the answer that I want. So this will give our code a higher degree of freedom. We can just alter the location as well as the number of isolator. We just types in the point that we want, and then it get our output. So after this, after we get all the points that we need, that we know, we are going to calculate the KEQ, CEQ, natural frequency, and then damping ratio for each of our idea. So for this, we are going to use a loop, which makes our things much more easier. They just calculate everything, so repeating for each ideas. And then after this, we get our arrays of data. So different idea, they have different KEQ and CEQ and so on, right? But this data, they are stored in a single array. So we are making this array a vertical matrix to make sure that we can tabulate them after this. So these are our data that we need. This will later be each of the different column that is in your table. Then after this, we tabulate our data. This set of data is for the table, and then we plot two graphs, the natural frequency against setup graph and the damping ratio against setup graph. So that's all. So when I run my code, the table will come up first because it's easier to tabulate this. And then the graph have to take some time. Okay, so this is my table. It got all the output and all the data that we want that's asked by the questions. And then these are the two different graphs that we need. So we are going to use this table and these two graphs for our analysis later on. So that's it. Thank you.